So, welcome. Today, let us take few important problems on derivative and mean value theorem. The first problem is if y is equal to e to the power sine 2x plus tan x whole to the power x, then dy then at x is equal to pi by 4, value of dy dx. Options: e to the power pi by 4, e to the power pi by 2, e, and only pi by 2. So the function y, it's a function of x only, but in both part, in power, function of x is there. But this one is some constant to the power function of x. We can differentiate it directly. But this is some function of x and power is another function of x. So it is not possible to find derivative directly. For that purpose, we have to take log of that part, because taking log, this one will be come down. For that purpose, let us take this is equal to e to the power sine 2x plus u, where u is equal to tan x whole to the power x. Therefore, dy dx, derivative of that, e to the power something, so e to the power sine 2x into derivative of that, it is equal to cos 2x into derivative of that is 2 plus u, its derivative is du dx. Now from there we have to find du dx, let it be 1. Now finding du dx, put it there and put x is equal to pi by 4, get result. For that purpose, take log of that, log u, x log of x, x log of tan x. Therefore, now differentiating both sides with respect to x, 1 upon u into du dx is equal to, this is two factors. So its derivative is 1 into log of tan x plus x into derivative of log function 1 by tan x, derivative of this, into derivative of tan is sec square x. Therefore, du dx is equal to u into that. U means tan x to the power x multiplied by log of tan x plus x. Sec square means 1 by cos square. So cos 1 cos, okay, x sec square x by tan x. Therefore, at x is equal to pi by 4, du dx is equal to, this is tan pi by 4 is 1, to the power pi by 4 is 1, this part is 1, log tan pi by 4, tan pi by 4 is 1, log 1 is 0. then pi by 4 sec square, cos square pi by 4 is 1 by 2, so that it is equal to 2 divided by tan pi by 4 is 1, so 2 du dx at that point it is equal to that. So dy dx at the point x is equal to pi by 4, this become from 1 e to the power sine pi by 2, sorry, sine 2x, x is pi by 4, so sine pi by 2 is 1, so e to the power 1. So 2, then cos 2x, cos 2x means cos pi, this is cos pi by 2, x is equal to pi by 4, so the pi, this is pi by 2, this becomes 0, so this into 0 plus du dx at that point is pi by 2, so our answer is pi by 2, so this is our answer. Then take our next problem. If fx is equal to tan inverse pi cos x minus 4 sin x by 4 cos x plus pi sin x, then fx is this, then to find f dash x, that is derivative of that function. So options 0, minus 1, 1 and tan inverse x. So rather it is a very simple problem, but argument of tan inverse x is a little bit lengthy, so let us try to simplify it first. For that purpose, you divide numerator and denominator of that one by cos x into 4 cos x into 4, so that this become tan inverse cos x and 4, so it is pi by 4 minus 4 is cancelled, tan x by 4 cos x cancelled, divided by this means it is 1, then plus pi by 4 tan x. Now it become a formula. It is 1 pi by 4 minus tan x by 1 plus pi by 4 into tan x. So it is equal to tan inverse a minus b, it is tan inverse a minus b by 1 plus a. So tan inverse a minus tan inverse tan x, so that it is 1 tan inverse, okay, keep it intact, tan inverse pi by 4, it is a constant, minus x, so that fx is equal to that. Now it is very simple form, so f dash x is equal to as because it is constant, its derivative is 0, minus derivative of that part is 1, so minus 1. So our this answer is correct. Now let us see what is the next problem. Next problem is y, if y is equal to tan inverse root over of x square minus 1, then x into x square minus 1 into y2 plus 2x square minus 1 y1, this value is equal to options 1, 0, root over of 2x square minus 1 and 1 by x square. So y is a function of simple function of x, in fact an inverse function. So we have to find this value. y2 means d2y dx2, y1 means dy dx, that is second derivative of y with respect to x, first derivative of y with respect to x. For that type of problem, to find second order and first order derivative, that is including y1, y2, etc., and there may be x square, etc. In that case, we have to do what to do. First, to differentiate this. After simplification, if there is any denominator, we have to cross multiply. If there is any square root, we have to square both sides. After that, that is, if needed, squaring both sides and then cross multiplying, we get a relation between y, x, etc. Once again you differentiate it, then you must get that result. The value of this will be something. So for that purpose, differentiate this with respect to x. Derivative of y is y1. It is equal to, it is tan inverse function. So it is actually 1 upon 1 plus x square, that is x square minus 1 into derivative of that. It is basically it is root over function. So 1 by 2 into root over of x square minus 1. Then derivative of this part, that is 2x minus 0. So its derivative, once again I am repeating, tan inverse function, that's why it is 1 upon 1 plus this square into, now derivative of that, it is square root, means this to the power half. So it is 1 by 2 into this to the power half minus 1, that is minus half. So in denominator, root over of x square minus 1 into derivative of this part, 2x. So that it is equal to x by, this is x, 2 cancels, this cancels, so it is x square into root over of x square minus 1. Just 1 minute, I check. Cancels, x square, x cancels, 2 cancels, so this all right. Now after differentiating and simplifying, we get one square root is present and some factors in denominator also present. So square and then cross multiply. Oh, 1x will be cancelled. So x is there. So squaring both sides and differentiating, so that x square into x square minus 1 into y1 square. y1 square means dy dx whole square is equal to 1. Nothing is there, only one constant 1 is there. So now differentiate both sides with respect to x. First I differentiate that. It is derivative of that. What would be that? y1 square, its derivative is 2 into y1 into derivative of y1. Derivative of y1 means dy dx. Its derivative with respect to x is y2. So y1 derivative of y1 square with respect to x is 2y1 y2. So that it is 2y1 y2 into this part is intact, x to the power 4 minus x square plus. Now y1 square intact, then derivative of that part, that is 4x cube minus 2x is equal to 0. Now in this type of problem, always we can cancel 2y1. 2y1 is there, y1 is there, and 2 can be taken common from there. So cancelling 2y1 from both sides, we get y2 into x to the power 4 minus x square plus y1 cancel, so 1 y1 is left and 2 is cancelled from there. So 2x cube minus x, 2 taken x is equal to 0. Now, in this case, 1, x also will be cancelled. Just 1 minute. Y2 into x square, taking common x square minus 1 plus x into y1 into 2x square minus 1 is equal to 0. Now cancelling x from both sides, we get y2 into x square minus 1 into x, y2 into x square minus 1 into x plus y1 into 2x square minus 1, that is equal to 0. So we get answer, and our correct answer is 0. Now our next problem, x is equal to e to the power t, y is equal to e to the power t sin t. Then the value of e to the power t d2y dx2 is option 0 sin t plus cos t, cos t minus sin t, sin t minus cos t. So these are 4 options. It's very clear that it's a parametric function, x in terms of t, y in terms of t. So for parametric function, finding dy dt and dx dt, we can obtain dy dx dividing by. After that, dy dx will be a function of t only. Then d2y dx2 can be obtained in the following way. Just you watch. So dx dt is equal to e to the power t. dy dt, product of two factors. It is e to the power t, derivative of this is that, into sine t, plus e to the power t, derivative of sine t is cos t. So that we get dy dx is equal to dy dt by dx dt. dy dt is that and dx dt is that. So our answer, this divided by e to the power t. E to the power t can be cancelled, so it is simply sin t plus cos t. It is dy dx. Now we have to find d2y dx2. That is, once again we have to differentiate this with respect to x, not t. It is a function of t. So we get d2y dx2 is equal to d dx of dy dx is equal to d dx of sin t plus cos t, because dy dx is that. This cannot be differentiated with respect to t, with respect to x. So we differentiate first with respect to t into, now adjust, dt dx. It is equal to cos t minus sin t into dt dx. Dx dt is e to the power t. Dt dx is 1 by e to the power t. This is d2y dx2. Our answer, we have to find e to the power t into d2y dx2. Therefore, e to the power t, multiply this with that, d2y dx2, it is equal to cos t minus sin t. Cos t minus sin t. So this answer is correct. So one thing, most of the students, they will commit common mistake. What is that? d2y dx2, it is d dx of that. Most of the times, students differentiate this with respect to t and with respect to t, but mind that it is with respect to x. So we have to d dx of that means d dt of that, then adjust. At that part, be careful about this portion of that problem. So our answer is cos t minus sin t. Next, if fx is equal to 3x square plus 4x into g dashed 1 plus g double dashed 2. G dashed 1 means derivative of gx function, and now put x is equal to 1. And gx is equal to 2x square plus 3x into f dash 2 plus f double dash 3. Then find the value of f dash 1 minus 12 f dashed 2. Fx is a function of this x and there is some constant g dashed x. So fx depends on g dashed. Gx once again it is a function of x and it depends on f dash, f double dash, etc. From there, tactfully we have to find this. For that purpose, we have to, because we have to find f dash 1 and f dash 2, so then first we differentiate fx, this one. F dash x is equal to 6x plus 4 into 1 into g dash 1. It is constant or derivative is 0. So f dash x is that. So now we have to find g dash 1 from there and put it there. G dash x is equal to 4x plus 3 into 1 into f dash 2. This is constant, derivative is 0. So g dash 1, we want g dash 1. So g dash 1 is equal to 4 plus 3 f dash 2. Now put this value over there. So f dash 1 is equal to 6 into 1 plus 4 into g dash x. G dash 1. G dash 1 is that 4 plus 3 into f dash 2. So that 6 plus 16 plus 12 f dash 2. So that f dash 1 minus 12 f dash 2 is equal to 22. So 22 answer. Oh, I've not given the options. So options are Options are 0, 10, 12 and 22. These are the options. So that our answer is 22. So option D is correct. Now, next problem. Next problem is if dash A exists, if dash A exists, then the value of limit x tends to a x fa minus a fx by x minus a. Options: fa plus a f dash a. Second option, minus f dash a. Third option, f dash a. Fourth option, fa minus a f dash a. Number 1, number 2, number 3, number 4. So given that f dash a exists, if f dash a exists, then we have to find the value of that. So f dash a means is equal to limit h tending to 0 f a plus h minus fa divided by h. This is definition of f dash derivative at a particular point. F dash x is equal to f of x plus h minus fx divided by h. At a particular point x is equal to a, this is the formula. Now, to evaluate that, but to take advantage of that formula, let us take x minus a is equal to h. This one. Because if we want h. Now as x tends to a, x tends to a, so h tends to 0. So that this become limit x tends to a means h tends to 0. Now express x in terms of h. X is equal to a plus h into fa minus a into f of x means a plus h divided by h, so that it is equal to limit h tends to 0 a fa plus h fa minus a f of a plus h by h is equal to limit h tends to 0. First we take this by that, h will be cancelled, so no need of this one. This by that h cancels, so fa plus limit h tends to 0, taking a common from this and that, fa minus f of a plus h divided by h. Now you see that this one is negative of that is it is minus f dash a, so that it is equal to fa minus a into f dash a. So we get the answer fa minus a f dash a. So this one answer, option D. Next, if y is equal to 3 to the power x minus 1 by 3 to the power x plus 1 into sin x plus log of 1 plus x base e, given that x is greater than minus 1, then at x is equal to 0, value of dy dx, this is equal to how much? So options minus 2 log 3, first option. Second option is minus 1, plus 1 and 0. So y is a simple function of x here. All these can be are very simple in that respect that directly they can be differentiated. So we can simplify this a little bit simplification is possible here. Y is equal to, it is 3 to the power x plus 1 minus 2 divided by 3 to the power x plus 1 into sine x plus log of 1 plus x. Base is e. This by that is 1, so it is equal to sine x minus 2. This by that is 1, so sine x. Now this by that into sine x minus 2 sine x by 3 to the power x plus 1 plus log of 1 plus x, and its base is e. Now differentiate. Dy dx is equal to, its derivative is cos x minus 2. It is now of the type u by v. So it is derivative of sine x is cos x into 3 to the power x plus 1 minus sine x into derivative of that. Derivative of that is 3 to the power x, its derivative is 3 to the power x into log 3 base e plus 0 divided by 3 to the power x plus 1 whole square plus, plus derivative of this 1 upon 1 plus x. Now we have to put x is equal to 0. So that cos 0 is equal to 1 minus 2 into, this is 1, this is 3 to the power 0 means 1 plus 1, it is 2 minus sine 0 is 0, that part is 0, divided by 3 to the power 0 means 1, 2 square plus 1, because x is 0. So that it is equal to 1 minus 4 by 4. This is 4 by 4 is 1 plus 1. So that answer is 1. Its answer 1. And that problem was given in WB JEE in the year 2012. Next. Acha, okay, let us stop today. Next day we take a few more problems. By this time, I request you, if you feel that this video is helpful for you, so then please like it, share it, and subscribe it. Okay, thank you.